So guys, as advertised, what we're going to do today is we are going to figure out how to do the same stuff that we've been doing with salts with molecules. You remember that salts are ionically bonded. It is a metal bonded to a non-metal. Well, guys, those are salts, and they have rules with Roman numerals and parentheses and polyatomic ions and least common multiples. And guys, the salts are complicated. There's a lot to keep track of when you're writing the names and formulas for salts. With the names, you got to figure out if they need Roman numerals. If they do need Roman numerals, you've got to work it backwards to figure out what they are. When we're talking about writing their formulas, you've got to find the least common multiple. You've got to figure out where the positives and negatives balance. If you need more than one polyatomic, you got to remember to put it in parentheses. If you only need one polyatomic, you got to remember to never put it in parentheses. If you need more than one atomic ion, you got to remember never to put it in parentheses. Guys, there's all sorts of rules and details. Here's the deal. Molecules are so much easier. This is so simple that we're going to be done like that, and that'll be our day, and you'll be able to practice. So guys, don't write stuff down until I tell you. So leading into this, here's the deal. For the last several days, we've been writing names and formulas for the salts. Well, guys, today we are going to first of all remember that salts are metals bonded to nonmetals or metals bonded to polyatomics. Today what we're going to do, guys, is we're going to do the exact same stuff with the covalently bonded substances that we call molecules. Now, guys, remind yourselves. Let me get in laser position. A salt is a metal bonded to a nonmetal, right? What's a molecule? What atom pairing creates covalent bonds and therefore molecules? Non-metal to non-metal, right? So guys, this is going to be all about how to name the molecules, and molecules are non-metals bonded to non-metals with one little exception. What's the one metal that forms covalent bonds? Hydrogen. Okay, good for you. All right, so guys, this then is the background. You need to remember that molecules are two nonmetals or hydrogen, because hydrogen is a freakishly strong metal. All right, this is where you want to start taking notes. Guys, this is so easy. You're going to like this. Here's how you work with molecules. You ready? You don't use Roman numerals. You don't use parentheses. You don't do least common multiples. None of that stuff. It's all gone for molecules. So what do? You use prefixes. You know what, guys? Don't even write all this down. Let's just say prefixes. Here's what you do. When you're writing these formulas, when you are writing these names, guys, you don't use Roman numerals, you don't use least common multiples, you don't do any of that. You use prefixes. And you need to know the prefixes from 1 to 10. Let's see how we do. What is the prefix for 1? Mono, like a monorail. What is the prefix for 2? Di, not bi, but di, like carbon dioxide. Do you guys know 3? 3, tri, we already knew that. What's 4? Tetra. Okay, so those are pretty straightforward, right? How about 5? Where do all of our generals meet? In a 5-sided building that we call the Pentagon. 5 is penta. Y'all know 6, right? Hex, right? Hexagon. 7 is weird. You guys know 7? We'll come back to 7. That could be our tough one. What's 8? You know that one is octagon. 9 sounds like 9. It's non. And then you know there are 10 years in a decade. So it's deca. So guys, the only one we need to talk about is 7. And 7 is hepta. So if you don't know these, write them down. Mono is 1. Di is 2. Not bi, we use di, like dioxide. Tri is 3. Tetra's 4. Those you knew. You knew penta's 5 because we have a pentagon. Then 6 I think you knew was hex. 7 you now know as hepta. It's probably the only one you just learned. You knew octa was 8, like the octet rule. 9 sounds like non, so that's pretty easy. And then you know there's 10 years in a decade, so there's really not much to keep track of here. So guys, there's only one weird rule that you need to keep track of when you're using these prefixes. I'll share with you the weird rule, then we will apply it 5 times, and then one more thing to talk about, and we're done for the day. Well, you're done listening to me for today, and you got a lot of homework to do. You guys ready? Not yet? How about now? You okay? Okay, so guys, here's the only weird rule, and I tried to make it stand out by underlining it. When there is only one of the first atom, do not use mono. For example, CO2 is not monocarbon dioxide. So if there's only one of the first atom, you don't use mono. So again, CO2 is carbon dioxide, not monocarbon dioxide, because you don't use the mono if there's only one of the first atom. And then guys, we also know that carbon dioxide is not carbon dioxygen, because the other rule carries over from the salts. You drop the ending of the second element and add IDE. But that's not new. It's just the same as the salts. You guys okay? You're all caught up? You're good? Not quite yet? What are the chances that my board dies again? I think I'm going to be okay. We'll see. At least I know how to fix it now. You guys good? All right, so guys, we are going to look at 5 examples. We're going to look at a few where I give you the name, you write the formula. I'm going to give you a few where I give you the formula, you write the name. And guys, this is going to go quick. And then there's one more little thing we need to talk about, and then we're done for the day. So guys, here we go. We are going to name this compound. So we know that S is sulfur. We know that F is fluorine, which we're going to call fluoride. So how do we name this? Well, first of all this, how many sulfurs are there? 1, but we don't call it monosulfur. That's the whole point behind that first rule. We don't call this monosulfur, we just call it sulfur. There's 1 sulfur, but because it's first, we don't add the mono. Now we know that the F is going to be fluoride, but there's 6 of them, so what is the prefix? Hexa. Guys, that's all there is to this. How does fluoride go? O-U? U-O. It's always the opposite of flour. Guys, that's all there is to this. You're done. That's it. This is just sulfur hexafluoride. That's all there is to it. Pretty straightforward, right? If you can remember the prefixes, you are money. So guys, what about this? Can I get rid of sulfur hexafluoride? Y'all got it? Okay, so I'm going to get rid of that, go over here. N2O. We've got nitrogen, we've got oxygen. How many nitrogens are there? 2. What's the prefix? Di. Do we put the di even though this is the first element? You do. The only prefix you won't use is 1 on the first one. So this is dinitrogen. Now guys, we've got 1 oxide. Do we add the mono? Yes, because it's not the first element, you add the mono. But guys, this, monooxide. Guys, if you have two vowels stuck together, get rid of one of them. So this is not monooxide. This would be dinitrogen monoxide. So typically you kill the vowel that's coming off the prefix, so it would be dinitrogen monoxide. Does that work for you? All right. One more. What about this? NO2. So is it mononitrogen or nitrogen? Nitrogen. Good. Now we've got two here. And guys, you'll notice that we keep both, and I probably said that wrong. You kill the vowel if it's the same vowel. You wouldn't call this doxide, it's dioxide. So you only get rid of one of the vowels if it's the same vowel. So this would be nitrogen dioxide. Are you good? Pretty straightforward, right? So guys, what if we then go in the other direction? It actually gets easier, because now you don't even have to remember the prefixes, you just have to decipher them. So what does dichlorine mean? Oh, you're not done writing it down. So guys, dichlorine, what do we got? Chlorines, two of them. What about oxide? What's our element? Oxygen. How many do we have? That's all there is to it, guys. That's pretty straightforward. Let's do one more, and then we need to talk about one other thing and we're done. Dinitrogen tetroxide. So guys, di is two, nitrogen is obviously nitrogen. So we've got nitrogen and two of them. Again, oxide is O. What is tetra? Guys, that's all there is to it. That's all there is to it. So can I let you in on a little secret when you take the test on Wednesday? You're going to see examples of both of these on the test. What happens if you get up here and you can't for the life of you remember that the prefix for 6 is hexa? What do? Go down and do the other part of the test. Because if you can't remember that hexa is 6 is hexa, I'll bet if you saw hexa, you'd remember it's 6. You know what I'm saying? So guys, if you get up here and you forget the prefixes, do the other part of the test where you're given the prefixes and you write the numbers, and many times the prefixes you don't remember will leap off the page in the other part of the test. You know what I'm saying? Little test. You guys know that trick, right? Taking tests. If you don't know the answer to a question, skip it, because many times there will be related questions later on in the test that give you the answers. All right. So guys, any questions on these? All right. Guys, one more thing to talk about. Let me just tell you right now. Two thoughts. One, we are not remediating the test that you're taking on Wednesday. The score you get is the score you keep. Thought number two is this. If you don't do well on the next test, this is going to be why. This is what's going to screw you up. Guys, this is important. So you're going to want to write this stuff down. So here's the scoop. Guys, you now know a whole new set of rules for writing names and formulas. So guys, go through this with me in your head. When you're writing the names and formulas for molecules, what do you need? Prefixes. When you're writing the names and formulas for salts, what do you need? Roman numerals, parentheses, ion charts, least common multiples, all of that stuff. But guys, here's the trick. They don't interrelate. So if you have a compound like NO2, don't do this. Watch. If you have a compound like NO2 and you go to name this thing and you break this in half and make this a 2 and this is a -4 and this is a +4, and if you go like this and if you call this nitrogen 4 oxide, that is absolutely wrong. Why? Because that's not a salt. And you don't name that with the rules for salts. You name that with the rules for molecules. And by the rules for molecules, this is actually called nitrogen dioxide. Guys, this is what's going to screw you up on the test. What you're going to see on the test, the first part of the test is going to be, well, the first part of the last page of the test. The first part is going to be names and formulas for salts. The second part is going to be names and formulas for molecules. Then the last part of the test is going to be a jumble. I'm going to throw them together. I'm going to give you formulas for salts and molecules all mixed together. So what's the first thing you got to do? Figure out which it is, and then name it appropriately. And then I'm going to give you the bunch of names for salts and molecules, and you've got to figure out which one it is, and then write the formulas appropriately. Guys, this is what's going to screw you up. You're going to get to the test, you're going to see NO2, you're going to break it in half, name it nitrogen 4 oxide, and you're going to miss points all over the place. And when you come back to me, I'm going to say, that's not a salt. You named it wrong. So guys, how do you avoid this problem? How do you know the difference between a molecule and how do you know the difference between a molecule and a salt? Okay, so good, Steve. Tell us more. Say it louder. Okay, so a salt is a non-metal and a metal.
Yeah, so
and what's a molecule?
A molecule is 2 non-metals.
Do you get it, guys? Guys, that's all there is to it. All you've got to do is look at the first element, because the second part is either going to be a non-metal or a polyatomic. So all you've got to do is look at the first element. What if it's a non-metal? It's a molecule. What if it's a metal? It's a salt. Guys, that's all there is to it. So let me put that to you in note form so that you have something that you can grasp a hold of. So guys, the tricky bit is this. You've got to be able to differentiate. Just means tell the difference between. You've got to be able to differentiate salts and molecules. But remember what we know. Salts contain metals and molecules don't. So guys, all you've got to do is determine whether the first element is a metal or a non-metal. What if it's a metal? Well, if it's a metal, it's going to be a salt. And guys, how do we write the names for salts? We watch out for Roman numerals if we need them. How do we write the formulas for salts? By balancing the least common multiple and using parentheses if we need more than one of a polyatomic. I don't even know if you need to write that down because you already know how to do this, or you should. It might be a good reminder. But then guys, what if it's a non-metal? Well, if the first element is a non-metal or hydrogen, then this thing will be a molecule, and you just name it using prefixes. That's all there is to it. And then when you write the formulas, we use the subscripts that are indicated by the prefixes. So guys, again, this is going to be the tricky bit for you on the test. This is the part that's going to make this a little more challenging. But I'm going to give you lots of practice. You're going to see examples of this in today's homework. You're going to see examples of this in Monday's homework. Guys, you will go into this test well prepared if you're engaged. If you're not, it's going to back up on you. But guys, that's going to be your choice because I'm going to give you lots of time to practice. Again, you have, all right, we're 2 minutes late. You have 50 minutes today to work on practicing on this. And if you'd like to work on your lab, that would be a great use of time as well. Then guys, Monday, we're going to grade this assignment, and I am not going to say another word to you unless I'm answering questions. And you're going to have a whole nother focused day to do more practice and finish up your labs in preparation for the test. Then guys, Wednesday will be your test, and Thursday, right at the end of Pride, will be the end of second quarter. So guys, look at this assignment with me, number 3. Grab your homework packet. You got it there? Okay, so guys, this is multi-paged. The first page, 1 through 20, these are all molecules. You need to practice on molecules first. Then when you flip it over to the back, you'll notice that it says mixed ionic covalent compound naming. This is a mixture of salts and molecules. Then down below, you're writing the formulas for a mixture of salts and molecules. So guys, this second page is the tricky part of the test. Then when you turn it over again, you've got more practice writing formulas and names. And again, guys, that is also a mixture. Well, the remainder of this is a mixture. So after page 1, which is only molecules, pages 2 and 3 are a blending together of both of them. And so you'll need to be able to tell the difference. Guys, I'll put the answers up on the wall. I would love to help you if there's anything that I can do to make this go better for you. But guys, the expectation is you're going to spend the next 50 minutes deeply engaged in getting this done. If that's not the case, I'll just make the due date for this at the end of class today, and we'll see if that doesn't change our focus. So guys, let's get these done. And again, I'd love to help if I can. Go get them.